Hello students and welcome to the lecture on roulette wheel selection. The 14th lecture in the lecture series for the course of Introduction to Soft Computing for Electronics and Telecommunication Engineering students of the 7th semester, Goa College of Engineering. I am Miss Purti Savardekar, the faculty in charge for this course. In the last few classes, we discussed and understood the role of selection operator in the genetic algorithm. The basic objective of selection is to select a pair of individuals for crossover. In today's lecture, we focus our attention on one of the most commonly used selection techniques, the roulette wheel selection technique. Let us begin. Roulette wheel is the same wheel that you must have seen in casinos or movies. It consists of pockets corresponding to various numbers. The players bet on any single number. The wheel is then rotated in one direction and a ball is swung into the wheel in the other direction. If the ball ends up resting in the pocket corresponding to the number that the player has bet on, the player wins. Note that every pocket here has the same size. Therefore, every number has an equal probability of ending up pocketing the ball. This analogy is considered for roulette wheel selection technique. A similar wheel is considered. However, the change is that the size of the pocket is not the same for every individual. The size of the pocket is made proportional to the fitness value or the expected value of the individual. Obviously, then a fitter individual has a higher probability of being selected and an individual with lower fitness value has a lower but some finite probability of being selected. For this reason, the roulette wheel selection technique is also known as fitness proportionate selection technique. Fitness proportionate selection technique. To understand roulette wheel selection better, let us consider an example. So in this example, we have considered 6 individuals, A, B, C, D, E and F, each with their respective fitness values 8.2, 3.2, 1.4, 1.2, 4.2 and 0.3. The roulette wheel is then designed in a way that the pocket for each individual is proportional to their fitness value. Obviously, individual A with the fitness value 8.2 gets the largest pocket and the individual F with the fitness value of 0.3 gets the smallest pocket. How do you think the pocket size is calculated? The sum of the fitness values, the total is 18.5 and 8.2 is 44.32% of 18.5. 3.2 is 17.30% of 18.5. 1.4 is 7.57% of 18.5. 1.2 is 6.49% of 18.5. And 4.2 is 22.70% of 18.5. And finally, 0.3 is just 1.62% of 18.5. The individual pockets then occupy the respective percentage of area, the same percentage of area on the roulette wheel. Now, a fixed point is considered and the wheel is spun. The pocket at which the wheel eventually stops is the individual that is selected as the parent. I hope that the idea is clear. Now, let us try to understand the algorithm, the pseudocode for roulette wheel selection. To design the pseudocode, we will need to know the procedure well and then encode each step of the pseudocode. So, first thing that needs to be done, as we have seen in the example, is to find the sum of fitnesses of all the individuals. Therefore, let T, capital T, be the sum of all the fitnesses. Now, we need to encode the act of rotation with respect to a fixed point. The entire roulette wheel represents the total sum of fitnesses. At the start of the rotation from a fixed point, the area covered by the pointer is 0. So at the start of at the start, the number is 0. And at the end of one complete rotation, the area covered by the pointer corresponds to the total sum of fitnesses, the final sum of fitnesses. The sum of fitnesses, so 0 to t. The rotation of the wheel then corresponds to adding fitnesses of each individual in a sequence, one by one, from position 0 to position t. Adding one by one is the rotation. For this, we can then initialize a sum variable, which will be initialized to 0. And then keep adding the individual fitnesses. Now, we need to encode the part that involves the randomness. In the entire rotation or in the entire process of summation of fitnesses, where does the wheel stop rotating? Where does the process of summation stop? We have to select a number that acts as a pointer. This has to be a random number because the wheel has to stop randomly. Let us call this random number r. The value of r should lie between 0 and the final sum t. It should stop between 0 and t. The process of summation or rotation must stop in between these values 0 and t. While the sum is being calculated, the wheel is being rotated. The sum s at that time will be less than this number r. But as soon as the sum becomes greater than equal to this number r, we stop the process of rotating. We stop the process of adding. The individual whose fitness value was added for the sum to become greater than r is the individual to be selected. I request you to pause the video now, go back to the beginning of this pseudocode explanation and understand it once again. Now let us summarize the pseudocode. Let t be equal to the sum of fitnesses of all the solutions. Let r be any random value between 0 and t. Let s be the sum which is initialized to 0. For every individual p in the population p, do s equal to s plus fitness value of the individual p. If s is greater than the value r, greater than equal to the value r, then return p. So, as we have seen, the roulette wheel is biased towards high fitness valued individuals. But it also gives a finite possibility of being selected to the lower fitness individuals, depending on their fitness values. The problem that this technique faces is that it is likely that high fitness value individuals only will keep on getting selected and the lower fitness value individuals may not get selected at all. This would result in only a few individuals being selected for crossover again and again and again. It may happen. And that, if happens, it will kill the diversity as we have discussed before. I hope that the content covered in this video was clear. Let us now continue this discussion in the live Google Meet. See you there. Thank you.